So describe what is meant by thermal decomposition, and is this an example of a physical or chemical change? So thermal decomposition is when electrons are broken down into smaller components through the application of heat, or sometimes other forms of energy, but mostly through heat. This process is a chemical change since the starting chemical is changed into several different chemicals by the end of the process. Okay. So question 2. Batteries generate electricity by consuming chemicals. So outline how a rechargeable battery works. So how does a rechargeable battery do what it does? So the chemicals in a battery are consumed to generate electrical energy. So the battery consumes the chemicals and produces electricity. However, once the chemicals have been consumed, no more energy can be produced. You can't obviously keep producing energy infinitely, otherwise we'd have a solution to the global warming crisis. So the question is then, what does a rechargeable battery do? So electrical energy can actually be put into the battery to cause the chemicals to return to their original state. So in the battery, the chemicals are still there. They're just in a different form. So if I put in electricity to reverse the process that I did to start with, I can actually change the chemicals back. And by doing that, I can sort of recharge the batteries. And that allows rechargeable batteries to be used repeatedly because the batteries can be discharged, all of the chemicals can be consumed, and then I can turn them back to their original state by putting in more electricity. So question 3. Glow sticks are a common device that exploits chemistry to produce its effects. Briefly explain the processes involved when using a glow stick. So I'm sure you've all played with glow sticks at some point. I know I definitely have. And they're fun things, but how do they actually work? So when you use a glow stick, it first needs to be bent and a loud cracking noise is heard. So you have to, crack the glow stick essentially. Now what that does is it releases two chemicals, and when they mix together, they form a new substance which glows, giving the characteristic lighting effects. Okay, so when you crack the glow stick, the two chemicals mix together. And when they mix together, you get that glowing because they react with one another to form light. Okay, so we know a reaction is happening. And that's why the glow sticks eventually stop glowing, because all of the chemicals have reacted together. You can't produce any more light because you don't have anything else to produce because there's no more reactions. That's how a glow stick works. So why are certain types of energy released or absorbed in chemical reactions? So why is energy even needed in these reactions in the first place? Since the chemicals that come out of a reaction and the chemicals that go into a reaction have different amounts of energy, chemical energy, there must be energy release or gain in order to balance that energy. So let's just look at petrol. Petrol, obviously we can burn. If we burn it, we get a lot of energy out. And carbon dioxide can't burn. So if you look at when we burn petrol, we try to burn carbon dioxide, nothing happens. So that means that carbon dioxide must have no chemical energy in it because it can't be used for anything. Whereas petrol must have a lot of chemical energy in it. Now the question then becomes, well, how can one suddenly turn into the other? And the easy way to solve that is by looking at the energy that's released in the reaction. So when the petrol burns, it releases a lot of energy. And that energy is part of the chemical energy in the petrol until it finally gets down to the carbon dioxide, which has very little chemical energy. So that's how we balance the two energies. The release or absorption of energy is just a consequence of the conservation of energy concept. So it's just a consequence of the fact that energy needs to be conserved. Okay? So state one example of a chemical change that involves each of the following energy types. So for heat, so we can extract mercury from mercury oxide through the use of heat. Light, so decomposition of silver chloride into silver atoms through the use of ultraviolet light. This is how the old school cameras used to work. Before digital, we had film, and just before the normal film that we use, the color film, we had black and white film, which used silver chloride paste, and when light struck it, it would turn black, and that blackness was related to the silver atoms. That's one reaction that involves light. And electricity. We can decompose water into hydrogen and oxygen. So we can use electricity, split water into hydrogen and oxygen. Okay? So that concludes today's lesson on reactions and their indicators. We've looked at what a reaction is and what indicators come out, and what are the common energy forms that are related to chemical reactions.